For the introduction of self-induction, it is a fundamental phenomenon in electromagnetism where a changing current in a conductor induces an electromotive force in the same conductor. It's significant in various applications, from the design of electric circuits to the functioning of devices like transformers and inductors.
Next, we are going to take a look about explanation of relevant electricity and magnetism concept. There are 4 different types, so we are going to take a look at one by one and stay tuned. So the first one is magnetic field from a current. A current flowing through a conductor generates a magnetic field around it. The strength in this field is proportional to the current, and that means the more current, the stronger magnetic field. This is flux linkage. The magnetic flux passing through the coil is called flux linkage. This flux linkage is directly proportional to the current in the coil. So the third part is changing current and changing flux. If the current in the coil increase, the magnetic field strength and flux linkage will increase too. Conversely, if the current decrease, the flux linkage will decrease. Last but not least is Faraday's law of induction. It states that changing magnetic flux through a coil induces an EMF in the coil. In that case of self-induction, the changing magnetic flux is caused by a changing current within the same coil.
So hi, my name is Aisha binti Maizuddin and I'm going to explain about the detailed exploration of self-induction in inductors. So the first one is the structure and components of inductors. The first one is wire coil. Wire coil is the primary element of an inductor. So wire coil is insulated and wound into spiral shape. The number of turns and spacing between them affect the inductance. The second one is the core material. In core material, there are air core. So air core is for the application that it requires minimal inductance or high frequency operation. And the other one is the ferromagnetic core. It is the materials like iron, ferrite or laminated steel cores increase the magnetic field strength and inductance. And the third one is the terminals. Terminals is the ends of the wire coil are connected to the circuits, and these allow the current to pass through. So the next one is the types of inductors. There are 4 types of inductors. The first one is the fixed inductors. The second one is the variable inductors. The third one is the toroidal inductors. And the fourth one is the ferrite base. So the next one is the application of inductors. So the first one is the power supplies. Power supplies is used in DC-DC converters. In switch mode power supplies, which is the SMPS, inductors are stored and it releases energy during each switching cycle. The second one is the transformers. The transformers is the self-inductions validates the voltage step up or step down in transformers. The third one is the filters in electronics. For the first one is the low pass filters. This allows low frequency signals to pass while blocking high frequencies. The next one is the high pass filters. This allows the high frequency signals to pass while blocking new frequencies. And the last one is inductive sensors. This detects the presence of metallic objects. It also measures proximity in industrial and automotive applications. Next is challenges in using inductors. The first one is the energy loss. The resistance in the coil causes the heat dissipation and this reduces efficiency. The second one is the size and weight. High inductance values often require large components, which can be impractical in miniaturized devices. The third one is the parasitic effects. At high frequencies, the inductors exhibit parasitic capacitance and resistance. These affect their performance. The fourth one is the saturation. In ferromagnetic core inductors, excessive current can cause the core to saturate, which reduces the inductance.
So there are 2 examples of future developments and innovation for self-induction, which is nanotechnology and superconducting inductors. For nanotechnology, the development of nanoscale inductors that could enable miniaturization of devices while maintaining high efficiency. While for superconducting inductors, by using these materials, it can eliminate energy loss and improving efficiency in power systems.
Okay, so let's continue with the examples of real-world implementations. So firstly, as the transformers. Self-induction is critical in transformers for voltage regulation and energy transfer in power grids. Secondly, electric motors. Self-induction helps generate the magnetic fields required for motor operation. And thirdly, wireless charging. The principle of self-induction is used in charging pads to induce current in receiving devices. And lastly, inductive sensors. These devices rely on self-inductions to detect metal objects and measure proximity. Okay, next is potential benefits and challenges. So for the first benefits is enables efficient energy storage and transfer in circuits. Second, forms the basis of many essential electrical technologies. And lastly, helps smooth and stabilize current flow in circuits. Last but not least is the challenges. So first challenge is energy loss. Heat dissipation due to the resistance in the conductor can reduce efficiency. Second challenge is complex designs. Precise calculations are required to optimize inductance. And the last challenge is limitations in high frequency. At very high frequency, inductors can exhibit unwanted capacitance, reducing their effectiveness.
So for the conclusion of this presentation, self-induction is truly a pillar of electromagnetism and is utilized in almost every modern application. It is comprehensive aids in the improvement of transformers, motors, sensors, and many other systems. It is unfortunate to note that problems such as energy loss will continue to exist. However, with superconducting inductors and wireless power being developed, many wonders of the future are bonus. In conclusion, self-induction is indeed important in the development of technologies which utilizes less energy and is environmentally friendly. And that is all from this. Thank you for listening.